Hi, I'm Prashant Tinakaran, an AI infrastructure engineer at Clockwork Systems. I'm very excited to share our latest product developments at Clockwork, focused specifically on GPU infrastructure observability and stateful resiliency for large scale AI jobs. AI at scale is no longer compute bound, it is communication bound. The AI training goes through phases of computation and communication. These workflows are highly synchronized and stateful. The GPU to GPU communication, the checkpointing, and storage I/O must remain perfectly coordinated and orchestrated. These synchronized collectives and storage I/O traverse thousands of links and transceivers. Congestion, cross-job contention, and frequent link and NIC flaps stall these ranks and forces jobs to restart, driving the real-world utilization far below the silicon's promise. Further, the infrastructure operators also juggle with multiple segregated networks, such as Ethernet for front end, RoCE or RDMA over Converged Ethernet, or InfiniBand for back end, each requiring careful tuning and configuration. And finally, frequent hardware failures force these jobs to restart too often, wasting valuable GPU compute time. Large operators report chronic slowdowns and job restart churn. For example, Meta reported 466 job restarts over a period of 54 days while training their biggest model, Llama 3. This illustrates how fragile fabrics translate directly into idle GPUs and blown schedules. Overall, AI teams face dysfunctional infrastructure fabric caused by three key factors: visibility gap into their GPU fleet and workloads, frequent hardware failures, and lack of clear attribution for performance losses caused by contention and congestion in the network fabric. The impact is clear: lower GPU utilization, longer job completion times, and reduced return on investment in GPU infrastructure. GPU to GPU communication, as I established, is the lifeline of AI training at scale. These jobs demand lossless, line rate communication, and without real time monitoring, the hardware failures can trigger slowdowns or restarts. High performance network fabric dedicated for AI training require real time, sub microsecond accurate telemetry from the physical network all the way through the communication libraries and workloads. They also need real time visibility and control across all the flows, such as GPU to GPU communication, for example, NCCL, RCCL, NVSHMEM, and storage to compute traffic, such as NFS, GPU direct storage, which is again enabled by different transport layer protocols such as RoCE or InfiniBand. Finally, the user and application traffic, which typically goes through TCP on the front end network. So there is diverse set of networks that the operators have to manage, and bottleneck in any of the above could slow down the AI workload, resulting in lower model flops. This is exactly why optimizing all stateful communication paths is key to unlock the peak performance and efficiency out of the distributed GPU infrastructure, whether it's used for training or large scale serving for inference. Introducing Fleet IQ, Clockwork software driven fabric that delivers unprecedented visibility into GPU fleets and workloads. These AI factories are only becoming more heterogeneous in terms of diverse accelerators, switches, NICs, smart NICs, transport APIs, and storage protocols. Vendor specific optimizations can help in short term, but they hurt portability and they create fragile fabrics. Clockwork's vision is a software driven fabric, a neutral layer that runs on any GPU, any NIC, any switch, any transport, and any protocol. Because the intelligence lives in the software, it normalizes vendor level differences, accelerates new functionality through software, and unifies the workloads across training, inference, and any other HPC applications. Fleet IQ implements the software-driven fabric vision via three core capabilities. One, the global clock sync. Two, the dynamic traffic control. And three, the workload failover. This all together is delivered as a cohesive software platform. First, let's focus on the global clock sync, which establishes cross-stack visibility. Clockwork's software-based global clock sync aligns every host, switch, and NICs to a common reference timeline with a sub-microsecond accuracy, which in turn forms the basis for extremely granular network telemetry. This telemetry forms the foundation for fine-grained, real-time insights into the network conditions of your GPU infrastructure. The operators see their network from two angles at once. Provisioning health, such as are the rail interfaces wired correctly, or are my firmwares correctly loaded? And on the other angle, fleet runtime efficiency. For example, which jobs or links are becoming outliers. Alerts fire on the first sign of trouble. Any trouble starting from link, node, or workload, before the users notice a slowdown, the dashboards are already turning red. Moving on to the second core capability, fleet failover. This fleet failover establishes workload resilience. Clockwork addresses the Achilles heel for AI infrastructure, which is link and NIC flapping and failures. In large clusters, disruptive NIC flaps or link flaps lead to job impacting events. This is very common in a large scale GPU infrastructure. Each time the job restarts from a checkpoint, it wastes hundreds and thousands of GPU hours because now you are recomputing the whole training job starting from the checkpoint. Clockwork's fleet failover changes this outcome. Instead of a binary success or crash failure like scenarios, the failures are more like gracefully absorbed. Like for example, a flapping NIC triggers immediate rerouting of the affected queue pairs to alternate healthy paths, preserving the collective integrity. Finally, the third, dynamic traffic control, DTC. Once the fabric becomes observable, the next leap is active control. Clockwork's DTC treats the whole network as a programmable fabric, steering the traffic dynamically in response to real-time telemetry. During the congestion events, DTC identifies imbalanced or colliding flows and shift traffic across the underutilized paths. This avoids in-cache collapse. It can also pace or delay specific queue pairs at the packet level, bounding the tail latencies that would otherwise stall the other synchronized collectives. Crucially, DTC runs entirely in software. It operates across Ethernet, InfiniBand, and RoCE fabrics without requiring proprietary switch features. Together with these three core building blocks, we form a new category for infrastructure, the software-driven fabric. By combining nanosecond-grade visibility, real-time traffic control, and workload-level resiliency, Clockwork's Fleet IQ delivers the first platform that actually closes the AI efficiency gap. In doing so, it transforms the communication from a brittle bottleneck into a programmable control plane, making the GPU infrastructure not just faster, but also economically sustainable. Our suite of product offerings include Fleet Audit, which performs posture checks for healthy cluster infrastructure. Before running the AI job, our audit suite helps users to validate for software configs, node health, front-end and back-end network health and readiness checks. This is to ensure the readiness of the cluster before running a long-haul AI job. Then, the fleet monitoring aggregates the infrastructure telemetry, which includes runtime link failures, including NIC flapping. Fabric topology and performance monitoring is also a part of the suite, along with RDMA congestion and contention monitoring. Further, the workload is also monitored through lightweight RDMA probes on the data path. This helps users gain deep visibility into GPU to GPU communication across all the corresponding AI jobs. This also helps in root cause analysis of job slowdowns by correlating network metrics along with job performance. Together, these provide a full picture from cluster readiness to runtime performance and workload behavior, helping operators diagnose slowdowns and also sustain high GPU utilization. Clockwork's Fleet IQ aims to be the software resilience layer that addresses the operational pain points of a modern AI infrastructure stack. The contrast is stark. Traditional communication stacks often lead to wasted cycles, job crashes, and inconsistent SLAs. With Clockwork, GPU infrastructure achieves optimal utilization. This results in higher model flops, higher good put per dollar, and always on resiliency, which keeps the AI jobs running round the clock 24/7. We are entering an era where the operational efficiency of the GPU infrastructure is highly reliant on high-performance communication fabric. Without rethinking the communication fabric, these multi-million-dollar systems risk stalling under their own complexity across different software layers. Software-driven fabric, powered by Clockwork's Fleet IQ, brings the resiliency, efficiency, and the scale required for the next decade of accelerated computing. Thank you, and we look forward to showing you more of our product in our live demo.